everyone. So let's solve this LeetCode medium problem, count of interesting subarrays. So the problem states that we are given an 0 index integer array nums and an integer modulo as well as an integer k. Now we need to find the count of subarrays that are interesting. And now what is the definition of interesting subarray? So a subarray nums L to R is interesting if it holds the following condition. So if count denotes the number of indices in the range L to R such that nums of I percent modulo equals to k, then a subarray is interesting if this count percent modulo is equals to k. Okay, so now we need to return an integer denoting the count of the interesting subarrays. So for example, what do we need to find? If we have the subarray L till R, then we will find out those indices such that nums of I percent mod is equals to k. Okay, so suppose out of means the number of indices which followed this were count. So now this subarray will be interesting if the count percent mod is equals to k. Okay, so this is like, let's try to observe this on the given input. So we have 3 to 4. Okay, 3 to 4. So since we need to find this nums of I percent mod equals to k, let's try to if this means nums of I percent mod is equals to k, then we will increasing the count. So in that case, let's replace this, create a new temporary array which will be storing 1 if nums of I percent mod equals to k, and if it is not equals to k, then we'll store 0. Okay, so here the k is 1 only, hence all the nums of I will be divisible by this. Okay, will be divisible by k. So the new array temporary means nums of percent mod equals to k. Okay, so here mod equals to 2. Mod is equals to 2. So we see 3% 2 is equals to k. So is equals to k. So we'll use 1 here. 2% 2 is equals to 0, which is not equals to k. So here we'll use 0. And here 4% 2 is equals to 0, which is not equals to k. So here we'll be using 0. So if nums of I percent mod is equals to k, then we'll put 1, else we'll put 0. Now what do we want? We want to find all those subarrays such that count of ones is equals to k, means counts of 1% mod is equals to k. That means we simply need to find some percent mod equals to k in a new array that we have created, right? Then it will be simpler to observe. So what do we need to do? We have 1 0 0. Now we need to find all those subarrays which has a some percent mod equals to k. So we know the subarrays will be 1 alone, then 1 0 alone, and then 1 0 0. Okay, so these three subarrays follow sum percent 2 equals to 1, because all the sums are 1 only. So 1% 2 will be 1 only, and which is equals to k here. Okay, so hence the output here is 3. So I hope you are able to, you are not confused how means this interesting is defined. First we count the number of indices in the range which follows this, and then that count percent modulo should be equals to k. Okay, so what will be the most brute force way of solving it? Obviously we'll be going through all the subarrays. We have done this a lot, many times. Okay, so what we'll do, we'll move the L from 0 till n minus 1, and the current count, and move R from what? L till n minus 1. Now the subarray that we'll get L to R, we need to find in this L to R, we'll iterate and see if nums of I percent nums of R here, nums of R percent mod equals to k, then we'll increase our count plus plus, current count plus plus. And if after we have iterated through the array, if this current count that we have, current count percent mod, if it is equals to k, then we'll update our global count which will be storing the interesting subarray. Okay, so in this way we'll be able to do this, since we see this will take a big of n square, and if it means iterate through the entire subarray one more, then this will take big of n. So we can maybe try to avoid this here, because then it will become n cube. So let's try to solve it in n square. So we see at each step what we are doing, we are iterating through the entire subarray. So instead of increasing the current count by iterating through the entire array, we'll be initializing the current count here only as 0. Now as soon as we get a R, that means we are means moving the previous subarray that we have to one step forward. Okay, so the current result that we have got till here, we'll just update that count with whether this is equal or not. So again we'll simply see, like instead of going through this, we'll be avoiding that, and if nums of r percent mod equals to k, we'll increase our current count, and if thus current count percent mod equals to k, then we'll be increasing. So we'll be able to get rid of this and we'll be able to solve it in big of n square. So let's see the code for this approach. So this is the simple code. We initialize the count variable. Now this is the start points, this is the end points. We initialize current count as 0. Now if nums of j percent mod equals to k, we'll simply increase the current count. And now for this subarray I to j, we need to check whether current count percent mod is equals to k or not. And since if it is, then we'll simply increase our global count, which will be storing the count of interesting subarrays. And in the end, we'll return the count. So this will be the big of n square approach to solve this problem, and the space is constant here. So let's see the constraints that we have. So constraints are till 1e5. So obviously this will go up to big of 1e10, and hence we'll be getting TLE here. So again, how will be like optimizing this? How will be moving from big of n square to big of n? And again, the question is simply what? We need to count something. We need to count something. So either like we'll be using a sliding window, or we'll be using DP, or we'll be using prefix sums plus hashing. Okay. Only these three things are possible whenever like we need to deal with subarrays or subsequences, and we need to return the number of counts of something which means satisfy a particular condition. Now most of the time what happens is we try to create a formula and then try to bring that formula in the form of a single variable, such that we are able to find the occurrences of that value previously encountered. Okay, so what we try to do every time using prefix sums, let's try to observe that and see whether that approach works here or not. Okay, so what we generally try to do is create a formula, create a formula and bring it in form of a single variable, then see its occurrences on left, and then what we'll do, we'll increase count by occurrences. This is what we do most of the times. So if we are at a particular index I, suppose 0 till I till n minus 1. Now if we are at this particular index I, how do we like find the, instead of I, let's take it R. Okay, this is the end point. How do we find all those else which satisfy the condition that we require? So what do we require? Suppose we have converted the array into zeros and ones. We have converted the array into zeros and ones. So hence what do we want? We want the sum percent mod equals to k. Hence what do we want? We want sum from L to R percent mod equals to k. This is what we want in the modified array. Okay, and we have modified in such a way that when it is divisible by, means when it mod, after taking mod, if it is equal, then we update it with 1, else we update it with 0. Now in the updated on, what do we want? We want some percent mod equals to k. If it is thus, then will be, that is a valid left point. Okay, that is what we want for a. So let's try to rearrange. Now how will we be able to get this sum from L to R? So obviously, for if the range is not changing, then what concept comes in mind? Prefix sums. Okay, so hence to get the sum of L to R, we will be using prefix of R minus prefix of L minus 1, and this percent mod, we need to make sure that it is equals to k. Now the next step is to, the first step we have formula, we have created a formula. The next step is to bring it in the form of a single variable. Okay, the next step is to bring it in the form of single variable. So we will be able to, means currently we will be able to know the value of prefix of R. Okay, and we need to find the number of these else on the left. Okay, so let's take the value that we have currently, the value we know currently on, means same side. So we know this prefix of R, we know this k. Okay, so let's bring them together. So that means we have, if we bring this k here and move this, so this means prefix of r minus k percent mod should be equals to what? Prefix of L minus 1. Okay. So hence what do we want? We want to find the number of L's on left such that their value is equals to prefix of R minus K percent mod. And we know like where if suppose mod is equals to 4 and uh, prefix of R was equals to 1 and K was 3. So this 1 minus 3 will become minus 2. Okay, so avoid negative scenarios in these conditions. What we do generally is we write it as prefix of R minus K plus mod percent mod. Okay, plus mod percent mod. So in this case, it will become minus 2 plus mod plus 4, then it will be percent 3. So it will be 2%. Okay, so this is what we do to avoid the negative conditions. Hence the final formula is we need to find number of values on the left which satisfy this condition. Prefix of r minus k plus mod percent mod equals to means prefix of l minus 1. So we need to find the number of l's on left which has occurred which means number of occurrences of this value, this entire value on the left. Okay, and how will be storing the multiple means occurrences of each value? Will be storing creating a hash map. Okay, so again this is the concept means this is falls in the category of prefix sum plus hashing question. So what we'll do, we'll simply create an unordered map of int comma int, and now what it will be storing? It will be storing what? It will be storing mp of whatever prefix we have here. So mp of prefix percent prefix sum percent mod, and we'll be increasing it at each step. Okay, so this is what we'll do, and then when we want to calculate for current R, we'll be finding this value in the map and count its occurrence and increase our result by this occurrence. Okay, and then we'll be updating our map. So this is the simple approach that will be used, and let's see the code as well for this approach. So this is the simple code for this approach. We initialize our long answer with 0. We create this hash map. Now initially the count of subarrays which satisfy the condition till 0, that means 0. So that means we need to find, since it is an empty subarray, so there will be 0 means initially, since we generate do this so that whenever for the subarrays which start at this value, means which subarrays which will be containing all the elements from 0 till r. So for those subarrays, this L means prefix of r minus prefix of L minus 1. So this L minus 1 exists, so that this exists. Okay, that's why for a prefix of 0 we do this one. I hope this is clear. We have used it a lot number of times. So at this system, the current count initially is 0, and this prefix becomes means prefix of 0 is 1 initially. Okay, now what do we want? If our IT% mod is equals to k, that means we need to increase our count. So hence we'll be increasing our count. Now the required result will be this count here will be what? The count is same as prefix of r. What was the formula? The formula was prefix of r minus k plus mod. So it will be simply count minus k plus mod. This is the requirement. And number of times this has occurred in the map, it will be the number of times it has occurred. So we will see from the map and increase it in our answer. And in the end, what do we want? The count that we have acquired so far, that is prefix of r equals to count here. We need to update it in our map. So we'll be updating it in our map. Okay, and we'll finally return the answer. So this is the big of n approach for this problem, as well as we have utilized big of n space as well. So this will be the most optimal approach to solve this kind of problems, and we have solved it multiple times. Whenever we are counting something and we can derive some formula, this is what we do. We bring it in the form of a single variable and find the number of occurrences of another variable on the left side, and we'll be done. So let's try to submit the code as well, and this is the same code that we wrote. Let's try to submit it and see how much time it takes. It should run pretty fast, I think. Yeah, it runs in 55 ms, which is real fast for like 1e6 means overall 1e6 complexity it will be, or 1e5 only it would be if we have means don't account the collisions. So yeah, this means we have solved these kind of problems. I hope like 10 12 problems we have solved. So I hope by now you are means expert in these kind of problems, and you are able to solve it on your own, and like just try to follow these steps. Create a formula, bring it in the form of a single variable, see its occurrence on left, and like increase the count by occurrences. This is what we need to follow for most of these kind of questions, and will be done. So I hope you were able to grasp the means the requirement for these problem. And if you did, make sure to like as well as subscribe. And if you have yet any doubts remaining, feel free to comment down. I will be happy to respond. Thank you so much for watching.